China's armored warfare story is one of the most dramatic and compressed technological transformations in modern military history. Beginning decades behind the world's major powers, China entered the tank age with almost nothing of its own. In the aftermath of the Chinese Civil War and the early Cold War, its armored forces were built almost entirely on foreign foundations, particularly Soviet designs. At this stage, China's approach was simple but strategic. Observe proven systems, learn how they work, and reproduce them as reliably as possible. These early tanks were not meant to be revolutionary. They were meant to function, endure harsh conditions, and establish a basic industrial and doctrinal foundation for armored warfare. Imitation soon became a powerful tool rather than a limitation. By copying and producing Soviet-style tanks, Chinese engineers gained first-hand experience in metallurgy, manufacturing, logistics, and battlefield requirements. Over time, these clones were quietly adapted to local needs, climates, and terrain. Each iteration introduced small improvements, better reliability, simplified maintenance, or adaptations for China's rivers, mountains, and varied geography. While the outside world often dismissed these vehicles as crude replicas, they were essential stepping stones in building domestic expertise. As geopolitical realities shifted and foreign support faded, China was forced to rely on itself. This pressure sparked a new phase of development innovation. Engineers who once copied designs now began experimenting with new layouts, weapons, and technologies. Decades of accumulated experience allowed China to move rapidly, skipping stages that had taken other nations much longer to master. What emerged was an armored evolution, unlike any other one that progressed from basic replication to sophisticated, digitally integrated combat systems in a remarkably short time. Today, Chinese tanks are no longer simple imitations of foreign machines. They are complex networked platforms equipped with advanced fire control systems, modern armor solutions, and high-speed mobility. This transformation from clunky replicas to highly advanced digital predators represents the fastest and most comprehensive armored modernization ever achieved by a nation. China's tank development journey proves that observation builds knowledge, imitation builds capability, and innovation builds power. During the 1950s and 1960s, China's armored forces were shaped by necessity rather than ambition. Lacking an advanced industrial base and modern tank design experience, China turned to the Soviet Union for assistance. The result was a generation of tanks that were largely licensed copies or close reproductions of Soviet models. Vehicles such as the Type 58 and most notably the Type 59 formed the backbone of China's early armored units. These tanks were not cutting edge, but they were robust, simple, and well suited to mass production qualities that mattered far more to a developing military than technological sophistication. This era was defined by practicality. Chinese engineers focused on learning how to build tanks reliably and in large numbers, ensuring that they could be maintained by crews with limited training and supported by a still maturing logistics network. Rather than pushing innovation, the priority was consistency and durability. The Type 59 in particular became a symbol of this approach, serving for decades and appearing in countless upgrades and variants. It brought modern armored warfare to the region and gave China a stable platform from which to grow. At the same time, China began tailoring its tanks to its unique geography and strategic needs. Lightweight designs such as the Type 62 were developed for southern China's mountains, jungles, and narrow roads where heavier tanks struggled to operate. Armor protection was sacrificed for mobility, allowing these vehicles to maneuver in difficult terrain, where speed and access mattered more than raw firepower. In parallel, amphibious tanks like the Type 63 reflected China's emphasis on river crossings and coastal operations. These designs combined water mobility with sufficient firepower to support infantry during amphibious assaults and riverine warfare. Although these tanks were often dismissed internationally as outdated or unsophisticated, their true value lay in what they enabled. They built China's manufacturing confidence, trained generations of crews and engineers, and established a domestic armored industry from the ground up. This foundational period was not about dominance. It was about survival, learning, and preparation. Without the rugged Soviet-inspired tanks of the 1950s and 1960s, China's later leaps in armored innovation would not have been possible. The 1970s marked a turning point in China's armored development, driven largely by political rupture and strategic isolation. The Sino-Soviet split abruptly ended access to Soviet technical support spare parts and design expertise that had previously underpinned China's tank production. What initially appeared to be a serious setback soon became a catalyst for change. With no external mentor to rely on, Chinese engineers were forced to develop their own solutions, pushing the country into an era defined by experimentation rather than imitation. This period saw the emergence of numerous prototype and test-bed vehicles, particularly within the WZ series. These experimental tanks were rarely intended for mass production. Instead, they functioned as rolling laboratories, where engineers could test new ideas and challenge existing design assumptions. Unconventional suspension systems were trialed to improve cross-country mobility, while more powerful smoothbore guns were evaluated to increase armor penetration. For the first time, Chinese designers seriously addressed night combat, integrating infrared searchlights and early night fighting equipment to allow crews to operate effectively beyond daylight hours. Light tank concepts were also reimagined during this era. Projects such as the WZ-132 aimed to combine high mobility with modern electronics, reflecting a growing awareness that speed, situational awareness, and flexibility could be just as important as heavy armor. Although many of these designs remained in prolonged testing phases and never entered full service, they provided invaluable engineering data and operational insights. Importantly, this decade redefined success for China's tank program. Rather than measuring progress by deployment numbers, progress was measured in knowledge gained. Every failed prototype, mechanical issue, or rejected concept contributed to a deeper understanding of modern armored warfare. Engineers learned how to integrate sensors balance firepower with survivability and design vehicles capable of evolving alongside changing battlefield conditions. By the end of the 1970s, China still lacked a world-class main battle tank, but it had achieved something arguably more important: independence in armored design thinking. The experimentation of this era laid the intellectual and technical groundwork for later breakthroughs. What began as forced self-reliance ultimately transformed China from a copier of foreign tanks into a nation capable of shaping its own armored future. The 1980s represented a critical phase in China's transition from experimental self-reliance to practical modernization in armored warfare. After years of internal testing and trial and error development, Chinese tank designers began selectively incorporating foreign technologies, particularly from Western sources, into domestically produced platforms. This period was defined not by copying a single model, but by blending the strengths of different design philosophies into workable, cost-effective combat vehicles. One of the most significant advancements of this era was the integration of modern fire control technologies. Laser rangefinders improved ballistic computers, and upgraded optics dramatically increased first-shot accuracy and engagement ranges. Alongside these systems, more powerful and reliable engines were introduced, giving tanks improved mobility and operational endurance. These upgrades transformed Chinese tanks from basic armored vehicles into credible modern fighting machines, capable of competing on the global stage. Design philosophy also shifted visibly during this decade. Earlier tanks relied heavily on rounded cast turrets inherited from Soviet traditions. In the 1980s, Chinese engineers began experimenting with welded angular turret designs that offered better armor layout and greater potential for future upgrades. Transitional designs tested new turret shapes, hull layouts, and protection schemes, acting as stepping stones toward a new generation of main battle tanks. Exports became an increasingly important driver of development. Tanks such as the Type 69 and later hybrid models were marketed internationally, bringing affordable and reliable armored firepower to countries that could not access Western or Soviet equipment. Export success not only provided valuable revenue, but also exposed Chinese designs to real-world operational environments, offering feedback that further refined reliability and performance. This decade was less about creating a single breakthrough vehicle and more about system integration and refinement. Chinese engineers learned how to balance cost, performance, and adaptability, ensuring their tanks could be upgraded rather than replaced. By the end of the 1980s, China had not yet fielded a top-tier main battle tank, but it had firmly escaped the shadow of pure imitation. The hybrid designs of this era bridged the gap between outdated legacy platforms and the advanced machines that would follow. They demonstrated that China could absorb global technologies, adapt them to domestic needs, and produce competitive armored systems on both national and international markets. The 1990s marked a decisive leap in China's armored warfare development, as modernization replaced experimentation as the central focus. Advances in global anti-tank weapons and battlefield sensors made survivability a top priority, forcing Chinese designers to rethink protection, mobility, and firepower as interconnected systems. This decade saw China move away from incremental upgrades alone and toward the creation of tanks that could survive and fight effectively on a modern battlefield. One of the most important developments of this era was the introduction of modular armor systems. Unlike earlier fixed designs, modular armor allowed protection levels to be tailored to specific missions and upgraded as new technologies emerged. Explosive reactive armor (ERA) became a defining feature, dramatically improving resistance to shape-charged munitions and anti-tank missiles. These upgrades breathed new life into older platforms, most famously through modernized versions of the long-serving Type 59, which remained relevant despite its Cold War origins. Engine performance also improved significantly during this period. More powerful power plants increased speed and maneuverability, allowing Chinese tanks to adopt more flexible and aggressive tactics. Mobility was no longer sacrificed for protection. Instead, designers sought a balance that would enable tanks to survive repositioned and strike effectively under modern combat conditions. At the same time, China introduced tanks that represented its first true generation of modern main battle tanks. Vehicles such as the Type 96 provided a cost-effective yet capable solution, combining solid firepower, improved armor, and modern fire control systems. Meanwhile, advanced prototypes like the Type 98 signaled China's ambition to compete with the world's leading armored powers, showcasing improved protection layouts and high-performance main guns. Export considerations continued to influence design choices. Customized variants were developed for international partners, allowing China to refine its technology while expanding its global defense footprint. These export projects provided valuable operational feedback and reinforced China's growing reputation as a serious armored vehicle producer. By the end of the 1990s, China had firmly crossed a threshold. Its armored forces were no longer dependent on outdated designs or superficial upgrades. Instead, they fielded tanks capable of surviving modern threats, while laying the groundwork for the high-end, digitally integrated systems that would dominate the following decades. The early 2000s through the mid-2010s marked China's arrival as a serious contender in top-tier armored warfare. During this period, Chinese tank development shifted from closing technological gaps to competing directly with the world's most advanced main battle tanks. This transformation was symbolized by the introduction of the Type 99 series, which represented the most powerful and technologically sophisticated tanks China had ever fielded. The Type 99 embodied a new design philosophy centered on dominance rather than sufficiency. It combined heavy composite armor with advanced fire control systems, high-performance engines, and sophisticated battlefield electronics. These tanks were designed for rapid maneuver warfare, offering both exceptional speed and protection. Integrated digital systems allowed crews to share targeting data, improve situational awareness, and engage threats more quickly and accurately than ever before. For the first time, Chinese armored units operated within a networked combat environment, comparable to leading Western forces. At the same time, China avoided relying on a single elite platform. While the Type 99 served as a heavyweight spearhead, more affordable tanks, such as the Type 96, continued to form the backbone of armored formations. This dual-track approach ensured both technological excellence and logistical sustainability. Units could field advanced capabilities without overwhelming budgets or maintenance systems. Exports played an increasingly prominent role during this era. Tanks like the VT-1 and later export variants offered modern firepower, strong protection, and reliable performance at competitive prices. These vehicles enabled China to challenge traditional arms suppliers and expand its influence in global defense markets. Export success also drove continuous refinement, as real-world operating conditions revealed strengths and weaknesses that could be addressed in future designs. Specialized roles also evolved significantly. Amphibious tanks were upgraded into credible naval fire support platforms, capable of engaging targets both ashore and at sea. These designs reflected China's growing emphasis on joint operations and maritime security. By the mid-2010s, China had firmly established itself among the world's leading tank producers. Its armored vehicles were no longer developmental experiments or regional solutions. They were fully modern systems blending firepower, protection, mobility, and digital integration into a cohesive and formidable combat capability. As China's armored forces matured, specialization emerged as a defining principle of tank development. Rather than pursuing a single one-size-fits-all main battle tank, Chinese planners recognized that the country's vast and diverse geography demanded a range of armored solutions tailored to specific missions and environments. This strategic shift marked a departure from earlier doctrines that emphasized uniformity and mass deployment, replacing them with flexibility and mission optimization. Heavy main battle tanks remained essential for high-intensity combat and breakthrough operations. Vehicles such as the Type 99 were designed to dominate open battlefields, combining powerful guns, advanced armor, and high-speed mobility. These tanks serve as the armored spearhead in scenarios where firepower and protection were paramount. However, China did not rely solely on these heavy platforms. Cost-effective tanks like the Type 96 played an equally important role. Balancing protection, firepower, and affordability, they formed the backbone of armored units and ensured that modernization could be sustained across large formations. This approach allowed China to maintain numerical strength while reserving its most advanced systems for critical missions. Geographic realities further drove specialization. Mountainous and high-altitude regions where heavy tanks struggled with engine performance and mobility required lighter platforms. This need led to the development of modern light tanks optimized for steep terrain, narrow roads, and thin air. These vehicles prioritized agility, advanced sensors, and sufficient firepower to counter threats without the logistical burden of heavier armor. Export-oriented designs added another layer of specialization. Chinese manufacturers produced tailored variants to meet the climatic, logistical, and doctrinal needs of foreign customers. Desert-optimized tanks, ruggedized systems for low-maintenance environments, and customizable protection packages allowed China to compete across a wide range of international markets. This diversified approach ensured that Chinese armored forces could respond effectively to varied combat scenarios, from high-intensity warfare to regional defense and expeditionary operations. By matching tank designs to terrain mission and budget, rather than adhering to a single doctrinal model, China maximized operational effectiveness. Specialization transformed Chinese tank development from a linear progression into a versatile ecosystem capable of adapting to both domestic defense requirements and global demand. From the late 2010s onward, Chinese tank development has entered a phase defined by speed, survivability, and emerging automation. Modern battlefields have become increasingly lethal, saturated with precision, guided munitions drones, and advanced anti-tank weapons. In response, Chinese designers shifted their focus toward maximizing mobility, enhancing active defenses, and integrating digital systems that allow tanks to fight as part of a connected combat network, rather than as isolated platforms. Mobility became a central priority. Upgraded variants, such as high-performance models designed for competition and rapid maneuver warfare, demonstrated significant improvements in engine power suspension systems and overall responsiveness. These tanks emphasized acceleration, stability at high speeds, and the ability to reposition quickly under fire. Enhanced mobility was no longer just a tactical advantage. It became a core survivability feature, allowing armored units to evade detection, disrupt enemy targeting, and exploit battlefield openings. Protection evolved beyond passive armor alone. Active Protection Systems (APS) were introduced to counter modern missile and rocket threats by detecting tracking and physically intercepting incoming projectiles. This shift reflected a recognition that no amount of armor alone could guarantee survival in contemporary combat. Layered defenses combining composite armor, reactive elements, and active countermeasures became standard features of advanced designs. Digitalization further transformed tank operations. Modern Chinese tanks adopted advanced crew interfaces, digital displays, and network-centric systems that improved situational awareness and coordination with other battlefield assets. Information from sensors, drones, and command networks could be shared in real time, enabling faster decision-making and more precise engagements. The tank increasingly functioned as a node within a broader combat system, rather than a standalone weapon. Perhaps the most forward-looking development of this era has been experimentation with unmanned and semi-autonomous platforms. Prototype unmanned tanks and crew capsule designs point toward a future where high-risk missions can be conducted without exposing human crews to direct danger. These concepts reflect a long-term vision shaped by advances in artificial intelligence remote control and autonomous navigation. Together, these developments signal a shift from traditional armored warfare toward a future defined by speed, information dominance, and reduced human risk. China's contemporary tank programs are not just responses to current threats, but deliberate steps toward the next generation of armored combat. China's tank development journey stands as one of the most striking examples of accelerated military modernization in modern history. In little more than 7 decades, the country progressed from having virtually no indigenous armored design capability to producing some of the most advanced main battle tanks in the world. This achievement was not the result of a single breakthrough, but of a deliberate and cumulative strategy built on observation, adaptation, and relentless refinement. In its early years, China focused on learning rather than leading. By studying foreign designs and reproducing proven systems, it established the industrial, technical, and doctrinal foundations necessary for armored warfare. These early efforts were often dismissed externally as simple imitation, yet they provided invaluable experience in manufacturing, maintenance, and large-scale deployment. Imitation became a tool for education, not a permanent state. Experimentation followed as external support disappeared and strategic pressures increased. Prototypes, test vehicles, and limited production models allowed Chinese engineers to explore new technologies, accept failure, and learn quickly. Each unsuccessful design contributed to institutional knowledge, enabling faster and more confident progress in later decades. Rather than waiting for perfect solutions, China embraced iterative development. Upgrading existing platforms became another pillar of success. Instead of discarding older tanks, China modernized them with new armor engines and fire control systems, extending their relevance while conserving resources. This approach allowed simultaneous modernization and expansion, ensuring that capability growth did not come at the expense of readiness. Exports played a crucial strategic role as well. By offering reliable and affordable armored vehicles to international customers, China gained operational feedback, strengthened its defense industry, and expanded its global influence. Export success reinforced domestic development, creating a cycle of improvement driven by real-world use. Today, Chinese tanks span a wide spectrum from cost-effective export models to highly advanced, digitally integrated main battle tanks that rival leading Western designs. This diversity reflects a mature and adaptable armored ecosystem, rather than reliance on a single platform. China's experience demonstrates that rapid progress is possible when learning is prioritized, failure is accepted, and long-term vision guides development. The result is the fastest and most comprehensive armored evolution ever achieved by a nation.
Importantly, these weapons are not widely issued. Their use is typically limited to operators with specialized training and mission profiles. This selective deployment ensures that such tools are employed only when their unique advantages outweigh the risks of complexity or limited versatility. In the hands of trained specialists, however, these weapons provide solutions to problems that conventional arms simply cannot address. In essence, special-purpose weapons embody the Spetsnaz philosophy of unconventional warfare. They are tools designed for scenarios where the rules of standard combat do not apply, where innovation, stealth, and precision replace brute force. Through these systems, Spetsnaz demonstrates that dominance on the battlefield is not solely defined by firepower, but by the ability to adapt and strike where the enemy least expects it. Decisiveness above all else. Rather than relying on uniform equipment or rigid doctrine, Spetsnaz approaches combat as a series of unique challenges, each requiring a carefully chosen set of tools. This philosophy acknowledges a fundamental reality of special operations warfare. Success is often determined in moments where hesitation, malfunction, or poor preparation cannot be afforded. At the core of this mindset is the belief in first-action dominance. Spetsnaz engagements are designed to be swift and conclusive, favoring weapons that deliver immediate results. Whether through silent elimination, precise long-range fire, or overwhelming close-range force, the goal is to control the encounter from its opening seconds. Weapons are selected not for sustained attrition, but for their ability to shape the fight before the enemy can respond effectively. Another key principle is adaptability across environments. Spetsnaz operators are expected to transition seamlessly between land, water, and urban terrain, often within a single mission. Their equipment reflects this requirement, emphasizing modularity and specialization rather than one-size-fits-all solutions. The ability to shift from stealth-focused operations to direct assault, or from reconnaissance to rapid extraction, is built into the very structure of their arsenal. Reliability remains non-negotiable. Spetsnaz doctrine assumes operations will take place in harsh conditions far from logistical support. Weapons must function under extreme stress, environmental exposure, and minimal maintenance. This explains the continued use of older proven systems alongside modern designs. Performance in real combat matters more than novelty or appearance. Ultimately, Spetsnaz weapons are viewed not as isolated tools, but as components of a broader tactical system. Each weapon represents a specific solution, integrated into planning long before the mission begins. Operators are trained to understand not only how to use their weapons, but when and why to employ them. This philosophy reinforces the defining characteristic of Spetsnaz operations, there is little margin for error. Equipment choices are made with the understanding that failure often carries irreversible consequences. In this context, weapons are not just instruments of combat, but guarantees of mission success, designed to perform flawlessly when there are no